We're going to have a look today at relative formula mass and several different types of calculations involving relative formula mass. There are a couple of key terms that we need to be aware of first of all, and their abbreviations. So AR is a capital A with a subscript R, is the symbol that we use to denote relative atomic mass. The A comes from obviously the atomic there, capital A, and the R is relative. We'll see later that it's relative because the masses are relative to the mass of 1/12 of a atom of carbon. And then this form MR here, which we use to denote relative formula mass. The M actually becomes, because in some cases we use the word molecular instead of formula. However, it's better to use the word formula because this can apply to, we can calculate the relative formula mass for things that aren't just molecular. So for anything that has a formula we can calculate an MR for, but we still tend to use the term MR here. And MR is the sum of all of the ARs in a compound. If we do a few worked examples, it will hopefully make some more sense. So we're going to calculate the MR for Al2O3, which is aluminium oxide. The first thing we need to do is write down how many of each type of element are present in the formula. So Al2, which means there's 2 times aluminium, there's 2 of them, oxygen, there are 3 of them. So 2 times aluminiums, 3 times oxygens. We then need to find from the periodic table the relative atomic masses of these elements. So aluminium has a relative atomic mass of 27, so I'm just going to write there that is the AR of aluminium, and oxygen has a relative atomic mass, or an AR, of 16. So then we multiply those together, which gives us 54 and 48, and these added together will give us a relative formula mass for aluminium oxide of 102. Let's have a look at another example. I use this example just to emphasize that we do have some elements, compounds which are made up of elements with just one letter symbols. So KOH, that's potassium hydroxide. There's simply one of each, one potassium, one oxygen, and one hydrogen atom present in each of these. Sorry, apologies for that. I'll write that out again. 1 times hydrogen. So let's replace these letters, these symbol letters, with their relative atomic masses. I'll need to use the periodic table to find those, but these are what they are. So obviously those are the answers there, which gives us a relative formula mass for potassium hydroxide of 56. Just to emphasize that you will need to find these on the periodic table or some other data source. Sometimes you can get a list of the elements with their relative atomic masses listed next to them. Let's have a look at our last example. I'm using this example because it's an example involving brackets. So first thing we need to recognize is this number outside the bracket means that anything inside the bracket is multiplied by the number outside of it. So the calcium is not part of the brackets, so there's 1 calcium atom, but in this formula there's an oxygen and a hydrogen, but they're both multiplied by the number that's outside the bracket. In this case that's 1 multiplied by 2 is 2, and 2 multiplied by 2, 1 multiplied by 2 is 2. So we've got 1 calcium. Calcium has the relative atomic mass of 40, oxygen has a relative atomic mass of 16, and hydrogen has a relative atomic mass of 1. Which means that will add up to give us 74. I haven't got another example here, but I just want to show you an example, a further example with some brackets. I'm not going to calculate the relative formula mass for it, but I'm just going to show you how we'd work out a slightly more complicated one. So let's take, for example, the compound magnesium phosphate. Now magnesium phosphate has that formula, Mg3, and in brackets PO4 twice. This phosphate group here contains 1 phosphorus and 4 oxygens. So if I was going to work this out, I'd say there's 3 times magnesium because they're not affected by the brackets, and then because there's 1 phosphorus inside the brackets but there's a 2 outside of it, which means we've got 2 phosphorus and 8 oxygens. Okay, so if we go over to this page, if you'd like to pause, or actually I'll put this here, in case you haven't got access to a periodic table, I've also included the AR of these particular elements here, so if you'd like to pause the video and have a go at these questions. And then the answers are there. Okay, so let's have a go now at a slightly more complicated thing to do, and this is using MRs to find an unknown element in a formula. So, example number 4. A carbonate formula has the formula XCO3. X obviously isn't an element, it's an unknown element. The MR of XCO3 is 84. Find the relative atomic mass, AR, of X, and hence the identity of X. So we need to start with what we know. We know that we've got carbon and oxygen in here, but X is unknown. So I'm going to put X as being our question mark, but then in this compound we've got 1 times carbon and 3 times oxygens. So we can work out the total mass contribution to the MR, to this 84, that's due to 1 carbon and 3 oxygens. So that's going to be 1 times 12 and 3 times 16 gives us 12 and 48, which means that the mass of the carbonate part of this formula is 60. So we know that the total mass, or the total MR, is equal to 84. So what we can do is say that the total mass minus the 60 due to the carbonate gives us 24. Okay, so just a reminder here that the total mass was 84. I've worked out the mass due to the carbonate, which is 60, which gives me 24. If I look on the periodic table, I'll find out that the element with a mass of 24 is magnesium. Let's have a look at example number 5. If you want to pause it quickly and copy it down. Okay, let's do the same thing here. We know that the formula is X2CO3. We don't know the identity of X, but there are 2 of them, so that's going to become important later on. We can work out the mass due to the carbonate, which we've already done in the previous example, but just to be sure, then that's 1 times carbon, 3 times oxygens, equals 1 times 12, and 3 times 16, 12, 48, gives us 60. So the mass due to the carbonate is 60. So 74, which is the total MR, minus 60, which is the MR due to carbonate, gives us 14. But that 14 is spread between 2 x's. So in this case, we're going to need to divide that by 2, which gives us 7. So the AR of x, of a single x, is 7. If we look at the periodic table, we'll find that that is equivalent to the element lithium. Okay, now I've got 5 questions based on this for you to have a go at. I will put questions 8, 9 and 10 there if you want to pause the video to write them down or have a go at them. I will then move down to questions 11 and 12, and if you want to pause the video and have a go at those. And then the answers are here. And that concludes the video for today.